SpaceX's Cargo Dragon helps out the International Space Station with a push. Russia's most important human spaceflight company isn't doing so well. Amazon's Project Kuiper starts delivering internet at super fast speeds, and we've got a bunch of news from across the solar system. As always, we'll have all of that and more coming up this week in Spaceflight. We'll be getting to those other stories shortly, but first up, Amazon's Project Kuiper has conducted speed testing of its first batch of operational Kuiper satellites. This week, it shared a video demonstrating downlink speeds in excess of 1 gigabit per second. That's like 4 times faster than what a regular Starlink will get you. To date, 102 production satellites have been launched, the first of which have recently become operational at their assigned orbit 630 kilometers above the Earth. The Kuiper team conducted tests using an enterprise-grade version of their customer terminal, for which there will also be a standard version. According to the company, this is the first commercial phased array antenna delivering gigabit per second speeds from low Earth orbit. The company chose to not share uplink speeds, and we're yet to see how a loaded network would perform, but this is still a promising milestone in Kuiper's path to service. The latency is slightly higher than its rival Starlink, but at 400 megabits per second, the standard Kuiper terminal will have a similar throughput. The higher latency is likely due to Kuiper's higher orbital altitude. The constellation will eventually occupy 98 orbital planes in 3 orbital layers, of which these first satellites are at the highest. Starlink now has over 8,000 satellites in operation and more than 6 million subscribers globally. Project Kuiper plans to reach over 3,200 satellites in its own mega constellation and needs to deploy half of these by the end of next July in order to meet its licensing obligations with the Federal Communications Commission. The full constellation needs to be completed by July 2029. 2 batches have been launched to date via Atlas V rockets, with a third scheduled later this month on September 25th. To meet those obligations, 5 further flights have been commissioned on board Atlas vehicles, while ULA's newer Vulcan rocket will launch the first of 38 missions for the constellation before the end of the year. Additional flights have also been booked aboard Ariane 6, New Glenn and Falcon 9 vehicles. We're expecting SpaceX to launch its third and final batch for the constellation towards the end of this quarter. Starlink is already installed and operating on a number of key airlines, including United Airlines, Air France and Qatar Airways. This week, US airline JetBlue announced that it will be the first to partner with Amazon's Project Kuiper to provide in-flight connectivity. The airline will enhance its free in-flight internet service, also known as Fly-Fi, from 2027. Speaking of internet in the air, 2 other companies have successfully pulled off a major first in air-to-space optical communications this week. General Atomics Electromagnetic Systems and Kepler Communications partnered on the project to perform bi-directional communications using a General Atomics optical communication terminal mounted on an aircraft, which locked onto a Kepler satellite in low Earth orbit. The test confirmed the ability to accurately point, acquire, track and transfer data both up and down in demanding environments. This marks a major milestone for the Space Development Agency's proliferated warfighter space architecture, proving that high-speed, secure laser communications can be achieved between airborne and space-based assets. The tests validated the interoperability and robustness of the agency's open standard for laser communications between systems built by different companies, proving they can work seamlessly in the real world. These tests used a Tranche 0 compatible Kepler satellite. Tranche 0 is the agency's first batch of demonstration satellites launched to prove out the basic technologies. Next year, the 2 companies will test 2 further systems using Tranche 1 satellites. These will form the first operational layer of the proliferated architecture, with far more satellites in global coverage, turning these early demonstrations into a working network. Over in deep space, the European Space Agency's Jupiter Icy Moons Explorer, or JUICE, flew past Venus. But this flyby got a bit more dicey than expected, as ESA lost contact with the spacecraft just a few weeks earlier. These flybys require some precise maneuvering, so not being able to contact the spacecraft was definitely far from ideal. So what happened? Well, on July 16th, the spacecraft didn't contact ESA's ground station in Spain at the planned time. After ruling out ground station issues and failing to reach the spacecraft through other antennas, the engineers confirmed the problem was with the spacecraft itself. JUICE is programmed to enter survival mode when multiple things go wrong, but that didn't happen this time. In survival mode, the spacecraft spins slowly, beaming a signal at Earth each hour, but JUICE wasn't sending any signals at all. So the engineers expected there might be a problem with the medium gain antenna. There were two possible solutions: wait for the next automatic reset in 14 days, or radio some commands in the general direction of the spacecraft and hope the low gain backup antennas would pick it up. With the Venus flyby coming up soon, waiting wasn't really an option, so the team resorted to blindly sending commands. After 20 hours and 6 failed attempts, they finally re-established contact with JUICE. Fortunately, the spacecraft was in good health, and the engineers determined the problem was caused by a software timing bug that meant the signal amplifier wasn't turned on when it was time to communicate with Earth. So JUICE tried to phone home, but its signal was just too weak to be detected from the ground. With communications restored, the spacecraft safely flew by Venus on August 31st, passing closest to the planet at 0528 Universal Time. The environment around Venus is much hotter than the cold and dark space around Jupiter that JUICE is designed for, so the spacecraft used its main high-gain antenna as a shield to protect its sensitive instruments. Unfortunately, that means we didn't get any pictures of the flyby, but ESA did confirm that the maneuver successfully helped the spacecraft pick up speed. At roughly 6,000 kilograms, JUICE is one of the heaviest interplanetary spacecraft ever launched, so it needs all the help it can get. Last year, it performed a double flyby of Earth and the Moon, and it will need 2 more flybys of our home planet in September 2026 and January 2029 to accelerate to the required 11 kilometers per second. After that, it will head towards its destination, Jupiter, where it's set to arrive in 2031. And now to a spacecraft that's been hanging around at Jupiter since 2016. NASA's Juno has finally completed the auroral family portrait of Jupiter's 4 largest moons, known as the Galilean satellites. Unlike our own northern lights, the planet's largest moons create their own distinctive light signatures in Jupiter's atmosphere, a phenomenon that our own moon does not produce. Io, Europa and Ganymede had already been found to leave distinctive auroral signatures, but Callisto's mark had remained elusive, until now. Jupiter's auroral oval shifted towards the equator in September 2019 when a high-density solar stream buffeted the planet's magnetosphere. This briefly exposed a faint but unmistakable auroral footprint which has now been linked to Callisto. Juno's ultraviolet spectrograph captured the signature, confirming that all 4 Galilean moons influenced Jupiter's mesmerizing northern lights. The James Webb Space Telescope also recently captured spectacular infrared footage of Jupiter's auroras. Astronomers have also been using the telescope to peer into the flowing coma of the interstellar comet 3I Atlas as it continues to pass through our solar system. The craft's near-infrared spectrograph captured a coma dominated by carbon dioxide at a ratio of roughly 8 CO2 molecules for every 1 of water. That's one of the highest CO2 to water ratios ever seen in a comet. Webb is just one of NASA's space telescopes observing this comet to gather more information about its size and chemical makeup. The Hubble telescope and the recently launched Sphere-X have also made observations, with Sphere-X confirming the CO2-rich signature. We've also seen some images from the Gemini South telescope in Chile, which even captured video of the object moving through the sky. This unusual chemistry could mean the comet formed far from its parent star, in a region where carbon dioxide ice was plentiful. Or it may have been altered over time by intense cosmic radiation, or perhaps is covered by an insulating crust that traps water inside while letting CO2 escape. Whatever the explanation, Webb's observations gave us a rare look at raw material from another planetary system, offering fresh clues about how worlds beyond our own may have been formed. Meanwhile, nearer home, the European Space Agency Solar Orbiter spacecraft has traced high-energy electrons in the solar wind back to 2 distinctive sources on the Sun: intense solar flares and massive coronal mass ejections. Solar flares are explosive bursts from small areas on the Sun's surface, launching quick bursts of high-energy electrons across interplanetary space. Coronal mass ejections, also known as CMEs, unleash broader, slower surges of particles from massive eruptions of hot gas and tangled magnetic fields higher up in the Sun's atmosphere. Scientists analysed the data from over 300 bursts of superfast electrons captured by Solar Orbiter as it flew through these electron streams over a 2-year period. This groundbreaking achievement provides the first direct evidence linking energetic electrons measured in space to their origins on the Sun. Being able to distinguish between these two types of energetic electrons is a major step forward for space weather research. The findings will improve our ability to more accurately forecast conditions that could disrupt our satellites and communication systems. The work could feed into ESA's forthcoming Vigil mission, which is scheduled to launch in 2031. Vigil will trail the Earth to study the side of the Sun for the first time and detect potentially hazardous solar events before they rotate into Earth's view, giving us a valuable heads up about their speed, direction, and impact. And to the Red Planet, NASA's retired InSight lander's mission may be over, but the data it collected between 2018 and 2022 continues to reshape how we see Mars, especially what lies beneath its surface. In a new Science Journal report, planetary scientists have revealed that the interior of the Red Planet is surprisingly, well, lumpy. Seismic data from more than 1,300 Marsquakes show that the planet's mantle contains dense, kilometer-sized rock fragments. Scientists believe that Mars suffered impacts around 4.5 billion years ago by colossal asteroids, or protoplanets, injecting debris deep into the planet's mantle. These rocky leftovers can measure up to 4 kilometers in size. They were thrust deep into the planet's molten magma oceans, where they've remained trapped ever since, thanks to the lack of tectonic plates on the planet. This has preserved a snapshot for us of the violent early solar system that Earth simply doesn't offer because our planet's geology keeps recycling its interior. So it turns out Mars isn't the smooth layered onion that scientists once imagined. It's more like a rocky road cake. And thanks to InSight, we've just had our first real taste. Acting NASA Administrator Sean Duffy has appointed a new Associate Administrator. Amit Kshatriya now becomes the highest-ranking civil servant in the agency. Kshatriya previously led NASA's Moon to Mars program, which aims to return humanity to the Moon as a first step towards exploring Mars. So this pick underlines the administration's focus on the Moon and beyond. Meanwhile, former NASA Administrator Jim Bridenstine has been making some spicy comments about the current plans to return to the Moon.
Instead of buying a moon lander, we're going to buy a big rocket.
Bridenstine was rather pessimistic towards orbital refueling and the sheer number of launches required for the current Artemis plan. But first of all, it might be a little confusing as to why the guy who served as NASA administrator under President Trump's first term was called as a witness to Capitol Hill. Well, it was all for a hearing titled, quote, "There's a bad moon on the rise, why Congress and NASA must thwart China in the space race." If you're less familiar with the whole political process, and trust me, I do not blame you, this is the same committee which Jared Isaacman testified at a few months ago back when he was the nominee for administrator. This opportunity allowed senators from both parties to ask questions, discuss, and hear opinions from 4 people so they could, quote, "examine legislative priorities for the upcoming reauthorization of NASA." There's a growing fear that the US might lose the new space race to China, and Bridenstine certainly seemed convinced that the current architecture for Artemis is insufficient for securing the win. SLS is expensive. Too expensive, according to Bridenstine, and its ongoing cost and throughput is not sustainable. But we have it now, so he thinks we need to use it. Along those lines, he praised the so-called Big Beautiful Bill, which secured Artemis 4 and 5 under the current plans with SLS Block 1B and Orion. However, the positives concluded there. His big item? The US doesn't yet have a lunar lander. There are 2 human landing system vehicles under contract right now, Starship HLS from SpaceX and Blue Moon Mark II from Blue Origin. The former slated for Artemis 3 and 4, the latter slated for Artemis 5. I think it's fair to say Starship has had a rough year so far, taking 4 attempts to achieve all mission objectives of their V2 ship. SpaceX chief executive Elon Musk is predicting a ship catch as early as 3 flights from now, or in other words, it's still quite some time away, and ship reuse is going to be rather important for Starship's orbital refueling. Bridenstine's concerns with the current situation even led him to say that, quote, "It is highly unlikely we will land on the moon before China." Starship requires in-space refueling for pretty much any mission beyond low Earth orbit, and Blue Origin's cislunar transporter will also require multiple top-ups of cryogenic liquid hydrogen and liquid oxygen. But although currently unproven, this is a capability which could open up greater tonnage to the lunar surface. For example, Blue Moon Mark II could deliver up to 30 tons in a one-way configuration or 20 tons when reusable.
We need Starship to be successful for a whole host of capabilities. It's also true that if they do what they're setting out to do, there's going to be over 100 launches from Cape Canaveral and Kennedy Space Center per year. from Starship. That also means there's going to be testing, there's going to be landing, there's going to be a lot of different things happening. Each time that's going to end up shutting down those facilities. And it puts us in a position where we could end up with basically one launch provider.
Bridenstine's comments have not been reciprocated by all, and in fact, it even sparked a lengthy ex-post from former NASA Administrator nominee Jared Isaacman. Taking a more optimistic view, he said that poking holes at the complexity of orbital refueling is incorrect. Bringing up the point that the private industry is investing in this capability, it will far expand the potential for exploration at a huge scale. All of this pessimistic talk about the current HLS options from Bridenstine does raise an interesting point. What is he trying to accomplish? Starship is big, Blue Moon is big, and yes, the Artemis architecture, as it stands, is incredibly complex. But isn't that the point? The mission goal isn't to visit for a few days and never return for 50 years like Apollo. It's to stick around and establish a permanent presence on the lunar surface. Finally, Bridenstine also criticised how NASA came to select Starship as the lander for Artemis 3, as the decision was made in the period after he left office when there was no NASA administrator, even though the selection process was started under his leadership and he appointed the people who made the final decision. So what are your thoughts on all of this? The current plan, which has been in place for years at this point, is undeniably complex. But is complexity the price of ambition? Or is Bridenstine correct to sound the alarm? I guess we'll find out in about 20 years' time when it will be really obvious what we should have done. Let's shift our focus to some other stories across space, starting in Germany, where launch provider Rocket Factory Augsburg has released video of the vibration test campaign for its Redshift orbital transfer vehicle. The tests were conducted in late July near the company's headquarters in Germany and simulated the intense vibrations of launch, shaking the vehicle across 3 different axes. Individual components have been tested in the past, but this latest test successfully proved that the fully integrated system could endure being given a good shake and still perform without a hitch. RFA completed a full mission hotfire test of Redshift's upper stage engine last July. The test simulated a nearly 10-minute burn, which would follow stage separation, followed by a 40-minute coast and then briefly reigniting for a short circularization burn. This latest test might have been one of the final steps of flight qualification for this 3rd stage, as RFA inches closer to the first launch of its RFA-1 rocket from the Saxonwold spaceport in Scotland. Heading a bit further north, the Norwegian spaceport, Andøya Space, has announced an agreement with the American company Astrobotic Technology. If you've been following the show, you might remember Astrobotic from their lunar landers, but they're not planning to launch to the moon from Norway anytime soon. Instead, Astrobotic wants to fly its reusable Zodiac vehicle from the spaceport, starting in 2026. Astrobotic obtained Zodiac through its acquisition of Marston Space Systems, which developed small hoppers. The rocket's main purpose is not to reach space, but to simulate lunar and planetary landings and to test various systems in flight conditions. The vehicle has made over 100 successful flights like these since 2015, and with the new agreement, its capabilities will soon be available to European customers. In neighbouring Russia, their human spaceflight program might be in big trouble. The country's main spacecraft supplier, RKK Energia, turned 79 this week, but when Director General Igor Maltsev sent a happy birthday message to employees, he wasn't celebrating, but very desperate. Apparently, the company has multi-million-dollar debts and is struggling to pay its employees. Maltsev complains about low morale and teams losing motivation. If things don't change quickly, Russia might lose one of its most important space companies. As Maltsev candidly put it, the situation is critical and only a miracle might be able to save the company. RKK Energia produces the capsules that support the country's human space efforts, the Soyuz crew vehicle, the Progress cargo resupply craft, and also the upcoming Oriole spacecraft and the modules for Russia's future space station. Without these, the country will have to turn to others, most likely China or India, if it wants to send its cosmonauts to space, or invest in trampolines. Unfortunately, none of this comes as a big surprise. Russia's space program has been in decline for a long time, facing delays and budget cuts across the board, and the war in Ukraine has all but dried up funding. Meanwhile, Roscosmos has been announcing ambitious plans for a new space station and a collaboration with China for a shared lunar base. But if RKK Energia doesn't make it, it's questionable whether Russia will even be able to maintain its presence on board the International Space Station. Fortunately, the station's dependence on Russia is decreasing, especially with that Dragon reboost this week, but losing one of the two main partners would still be far from good news for the orbital lab. Meanwhile, in China, launch provider Space has completed testing of its upper stage vacuum engine for the forthcoming Kinetica 2 or Lichen 2 vehicle. The Kinecore 4 or Licheng 4 is a 20 kilonewton engine which is capable of supporting missions to geostationary transfer orbits and beyond into deep space. These validations were conducted at the company's dedicated test facility in Konghua in southern China. They followed successful static fire testing in July of the sea-level YF-102 engines, 9 of which will power the vehicle's first stage. Space has also been testing its 3D printed Kinecore 1, a 294 kilonewton engine that will support the company's entry into space tourism with the forthcoming Lihong 2. Space is one of several Chinese companies planning to enter this market, including newcomers Interstellar. And no, you're not the only one getting déjà vu looking at this design. Space has been developing its own launch infrastructure at the Zhoushan Satellite Launch Center for almost a year now and tested its ground stage equipment in April. The Kinetica 2 is a little smaller in height and diameter than a Falcon 9 at 53 meters tall, with roughly half the payload capacity to orbit, depending on the configuration. Initial flights will be expendable, with plans to introduce a reusable variant by 2028. The vehicle is expected to take its maiden flight later this month, and it's scheduled to carry a prototype of the Qingzhou, or Lightship, cargo transporter. This low-cost expendable spacecraft is the first of 2 new vehicle designs that will service the Tiangong space station. The Chinese Space Agency awarded its first 2 commercial resupply contracts last October. NASA is looking for someone to reinvent the wheel. No, I'm not joking. The agency launched the Rock and Roll with NASA challenge, for which they want someone to invent a wheel that can survive on the moon. So what's the problem with regular wheels? Well, the moon is not a kind environment. The lunar night can get as cold as minus 255 degrees Celsius, while the lunar day can heat up to 121 degrees Celsius. That's a range of 376 degrees, throughout which material properties can change dramatically. And if you want an operational moon base, you can't really stop during the lunar night, as it lasts 2 weeks. So any wheel needs to work throughout the entire temperature range. What's more, the lunar dust, or regolith, is notoriously sharp and abrasive, which provides a true challenge if you want your wheel to last. But we've had wheels on the moon before. What's the problem with them? Well, they're all designed for low speed and short duration missions. NASA wants a wheel that can drive around at high speeds, carrying lots of cargo, and last a long time too. So the agency is calling student teams, individual inventors, aerospace companies, anyone with a good idea really, to invent a wheel that can do it all. The program has 3 phases, starting with design proposals and ending in June 2026 by testing prototypes on an obstacle course of simulated lunar terrain. Throughout the program, NASA plans to hand out a total of $155,000 in prize money to the winners of each phase. I guess that might set the wheel rolling. It's time for your weekly space traffic report provided by Next Spaceflight. This week, SpaceX launched 5 Starlink missions, adding a total of 132 satellites to the constellation. While these were mostly normal Starlink flights, one of them featured a brand new booster, and another the 500th successful recovery of a Falcon booster. We also had the surprise launch of an Israeli Shavit 2 rocket, lofting a synthetic aperture radar surveillance satellite into low Earth orbit. As is usual for the country's launches, but a bit of an oddity worldwide, the rocket flew westward over the Mediterranean, delivering its payload into a retrograde orbit. Later in the week, China snuck in 2 more launches, with a Changzheng 3C lifting off from Xicheng and a Ceres 1 from Galactic Energy launching from Zhoushan. But the most interesting things happened in space this week. Of course, we had the aforementioned Venus flyby of ESA's JUICE mission, but the International Space Station got a little bit of a boost. That's not particularly special on its own, as the station regularly gets boosts to maintain its orbit. What was different this time was the spacecraft that boosted the station, a Dragon. The CRS-33 cargo Dragon, which was launched on August 24th, is outfitted with a special boost trunk. This trunk features extra propellant tanks and 2 Draco engines. Dragon lit these engines on September 3rd at approximately 18:15 UTC, and over the following 5 minutes and 3 seconds, it raised the station's orbit. But wait, didn't Dragon dock to the station's forward port? Wouldn't that mean it lowers its orbit if it fires from the trunk? Well, Yes, it would, but the ISS has a trick up its sleeve. In preparation for the manoeuvre, it flipped over 180 degrees to face retrograde, allowing Dragon to fire in the correct direction to raise the orbit. Of course, Dragon isn't the first visiting vehicle to boost the station. Usually a Russian Progress resupply craft gets the job, but in recent years it has also been done by Northrop Grumman's Cygnus and last year also by another Dragon. Though that one used its regular thrusters and didn't have the special trunk. Now with this trunk, Dragon has 3 times more reboost capacity compared to Cygnus and about 1.5 times compared to Progress. The CRS-33 Dragon is set to stay at the orbital outpost until late December or early January. During that time, it will perform a series of longer burns to maintain the station's altitude. With another month wrapped up, it's time for some numbers. Throughout August, we saw 28 orbital launch attempts, half of which were by SpaceX with its workhorse Falcon 9 rocket. As usual, SpaceX was followed by China, which attempted 8 launches. Unfortunately, one of them didn't reach orbit. The Juche-2E launch on August 15th ended in failure. Next week, Falcon 9 is scheduled to launch 3 times. From California, we'll have a Starlink launch and a mission for the US Space Force's Space Development Agency. From Florida, Falcon 9 is set to launch an Indonesian communications satellite into geostationary transfer orbit. There's also a launch from China on the manifest, as a Chang'e 6A is expected to fly from the Taiyuan Satellite Launch Center. On September 11th, the Progress MS-32 resupply mission is set to lift off from Kazakhstan. To prepare for the spacecraft's arrival on the 13th, the Progress MS-30 craft is set to undock from the ISS 2 days earlier on September 9th. Finally, we'll also have a total lunar eclipse on September 7th. As the moon passes through Earth's shadow, the full eclipse will be visible over most of Asia and parts of Australia and East Africa. If you're in Europe or most of Africa, you might be able to see a partial eclipse during the moonrise, and if you're west of the Pacific, you might catch it during moonset. Our American viewers will, unfortunately, have to miss out, as this lunar eclipse won't be visible from that continent. You did get a total solar eclipse last year, though. Anyways, I've been Caton for NSF, thanks for watching, and goodbye.